Welcome. So in this tutorial, I'm going to show you how you can select some specific columns in a Pandas data frame. So importing the Pandas library as PD in the beginning. And in this tutorial, we're going to use a scikit-learn dataset. We're not going to use any kind of dummy dataset. So from scikit-learn, we are importing datasets. I run the cell, and we're going to load the diabetes dataset that is built in for scikit-learn. So as I do datasets.load data diabetes, our dataset variable contains two components. One is the data component, which is if you take a look at the type of that data component, it's going to be an n-dimensional numpy array. And there is a second component which is called feature names. So if I do dataset.feature names, you can see that we have a few column names there. So if I want to create a data frame from this dataset that I loaded using scikit-learn's datasets, we do pd.dataframe, and as data we take the datasets data portion, and as columns we take the datasets feature names portion, and that's it. So we have our data frame ready. It's now in tabular format. So we have 10 columns in this dataset. Say we're going to select a few of them. How we're going to do that? Well, there are many different ways in selecting the columns. So first, what I'm trying to do here is I'm creating a list variable, calls to keep or columns to keep, and say from this data frame I'm just interested to select the first four columns: age, sex, BMI, and BP. And we are going to discard the rest of the columns, S1 to S6. So we can actually send these calls to keep list inside this df, and then this is going to give us the first four columns only. This is one way of doing it. It's subsetting of our data frame. The same functionality can be achieved with iloc. So we know iloc has two components here. The first component is just a colon, which means all the row, and the second component is the number of columns. So here we are having a slice colon 4, that means start from 0 all the way up to third column. That gives us the first four columns for iloc. For iloc, we also could use list as our second argument, where we can actually provide 0, 1, 2, 3, the index number of our columns, and it also provides us similar functionality. So for iloc, the second argument is going to be an integer value. If we want to use the name of the column, then we have to switch to loc, where we can actually use our calls to keep variable, which is a list, as our second argument, and it also provides us the same result. So these are two different ways of selecting a subset. Now with dfloc, here is an interesting thing. If the interviewer asks you a question whether you are capable of finding alternating columns, then you can actually use the second argument just like this, colon, colon 2. This means start from 0 all the way up to the final column, but skip by 2. So this is going to give us the alternating columns, because if you take a look at the columns, you see that sex has been skipped, BP has been skipped, S2 has been skipped, and then S4 and S6 and so on, and the rest are only selected. Let's take a look at some other examples in this case. So another way of achieving the same thing is with df.drop. df.drop has an argument or an option inside of it, which is columns, which is going to be our list of columns to drop. Now here is a trick. Now if you take a look at our data frame. So I'm using a new cell and calls to keep. Here you see that we just have 4 columns to keep, and our data frame is actually containing 6 more columns, and we're dropping them. So if your number of columns is small, relatively small to the number of columns that you're going to discard, you can actually use a trick, which is using a list comprehension. So inside these columns, I'm again creating a list, which is going to be the list of columns that I'm going to discard. And I'm just using the list comprehension with access equal to 1. Here again, with this option, I'm just selecting our first 4 columns. I'm just dropping everything that is not inside our calls to keep variable, which are age, sex, BMI, and BP. df.take also provides us similar functionality. As an argument, we provide again the index numbers of our columns of our interest, and access equal to 1 will provide us with the first 4 columns. Similar functionality. So here you just need to be careful that it only takes list as its argument if you're using take to do the same thing. The same thing can be achieved with filter, but this time calls to keep variable or the name of the columns actually can be sent. And it's a much easier way for myself using column names rather than going through the indexes or columns. df.get is similar to df.filter. The only difference is that for df.filter you will need the axis variable set to 1, but for df.get you don't have to set any axis variable because df.get works at the column level. Now here is an interesting thing that I like to discuss with you. So if I sort the columns of our data frame, then you can see that it starts with age and then BMI, BP, S1 all the way to S6, and then we have the sex variable. So I'm just sorting the column names, and it is like in ascending order. It starts with A all the way to S and so on. Now if I do df.sort index and use truncate, another method for pandas, and I'm just putting here before S1, which means that anything that is before S1 and after S6, which means any column that is after S6, axis equal to 1 or column wise, truncate them. So this is going to keep only the S1 to S6. So this is a trick that you can use whenever the interviewer asks that, can you, if your columns are adjacent and if you know them, can you take everything before and everything after those adjacent set of columns? So this is a cool trick that you can use using truncate, but for using truncate you need to actually sort them out. Here you see that df.columns here, its type is an index. You can think of it as a list, because we've seen that columns of df, they can be kind of sort of thought of as a list. They work in a similar way to a list, because in df.columns and you do colon colon 2, which means from start to end go and skip by 2. So we are just skipping every other column here with this slicing technique. So here you can see that the df.columns, this technique is actually giving us age, BMI, S1, S3 and S5. And if I start from 1 all the way up to the end, this is actually starting from 6 and then skipping by 1. Why am I showing this to you? Because sometimes the interviewer may ask you, can you keep only the columns that are in the even indices? So this is a cool way of doing it. As df.columns, they can be seen as a list or like index, and you can do slicing. In this way, you can actually create 2 different data frames. One will contain columns that are in even position, 0, 2, 4, 6 and so on, and data frame containing columns is in odd positions, 1, 3, 5, 7, and so on. So this covers a great deal of things with data frames and how you can actually select some specific columns from the many different techniques. So if you are getting benefited from these tutorials, please subscribe and click on like. See you in the next lecture.